Alright, quickly looking at this graph of the orange function. What is the domain? Domain here you should find is negative infinity to infinity. Some of you fancy kids are going to say all real numbers. All real numbers. Now I don't know if you've ever looked at this closely, but why are we writing all real numbers? Why can't we just write all numbers? Is there any such thing as a number that's not real? Turns out that we have this thing called an imaginary number. An imaginary number is something that we can't really visualize very well, but it happens to be the square root of a negative number. Right? So you guys all know that you can't take the square root of a negative number and have a real solution for that. But you can have an imaginary solution for that. Alright, here we go. It's about to get weird. Here's our rule for imaginary numbers. I, which is the imaginary number, I equals the square root of negative 1. Okay? So if we wanted to turn our square root of negative 5 here into an imaginary number, we would just break this up into the square root of 5 times the square root of negative 1. Right? We can do that according to our rules of radicals. Now we can just turn this negative 1 into an I according to our imaginary numbers rules. This becomes I times radical 5. Okay? So we can do the same thing if we had the square root of negative 18 here. Well, we can break this up into square root of negative 1 times square root of 9 times square root of 2. Right? This becomes I, this becomes 3, and this stays how it is. Sorry. And here we go. Our final answer is 3I radical 2. Alright, and we're doing all this using our radicals rules, and all we're adding on is this rule right here. Our imaginary number I equals the square root of negative 1. So anytime we can factor out a square root of negative 1, we should do that and replace it with I so that we know that it's an imaginary number. Alright, try that on your own here. How do you find the square root of negative 24? Once you're done with that, try the square root of negative 50. Okay, I did these two, and here's what I got. 2I radical 6, and then 5I radical 2. You guys should be comfortable turning the square roots of negative numbers into imaginary numbers. And these imaginary numbers have properties that are kind of similar to variables. So we can add and subtract imaginary numbers just like they're variables. So here's an example, 4 plus I plus 2 minus 7I. And the i's are both imaginary numbers. Well, I can take my like terms here. I have two constants, and then I have two imaginary numbers. And I can just add like terms. That 4 plus 2 is 6. I minus 7I is negative 6I. And there we go. That's the most simplified version of that number. Now that number right there is actually called a complex number. And it's called a complex number because I have part of it that's imaginary, right? Part of it has an I in it, and then part of it is a real number, right? That's just 6, which is a real number, and then negative 6I, which is an imaginary number. So you're going to see a lot of these complex numbers when we're dealing with our quadratics, because our quadratics sometimes don't intersect with the x-axis, but they always have two solutions. But here's the thing, the two solutions are not always real. Sometimes they're complex numbers as well. Okay, one more property of these imaginary numbers. So what if we take this example, I plus 2 times 2I minus 1. Well, let's start off by foiling this out. If I FOIL this, I'd get 2i squared minus I plus 4i minus 2. Well, remember our rule that I equals the square root of negative 1? Right now we have I squared, so we want another rule that has something to do with I squared. If we square both sides of this rule right here, then we get I squared equals negative 1. And that actually holds true here. So whenever we see I squared, we can replace that with the number negative 1. So now we have 2 times negative 1 minus I plus 4i minus 2. And oops, I forgot to simplify this, and I can do that now. But it becomes negative 2 plus 3i minus 2. Final answer, 3i minus 4. Okay? If you guys are comfortable with that, then try this one on your own. What is the complex number that can be represented by this? 8 plus I times 6 plus 2I. Right, first step is to FOIL this out. After you FOIL it out, then you replace the I squares with negative 1, and then you'll be left with a complex number. Good luck. Let me know how it goes.